In this part is again the manual CNC program, part program we are seeing. So in this box turning experiment, let me see how to write a box turning experiment and how to do the animations. So this is the question is write a part program for step turning operation in the given sketch using box turning cycle. So already we said no, the cycle is a turning cycle or can cycle is repeated operations. So this is like the same step turning cycle, but here we are going to use box turning cycle code. Okay, the given sketch you can see is the diameters here, the raw material is given as 34 and length 60. So for the 34 diameter and the length 60, now you are going to make this 34 to 28 and 28 to 16 and 16 to 10. So reduction of the diameter we are going to do it, and as well as the length for this is for 10 dia it should be for 10 mm length, and for 16 dia it should be for 22 mm length, and for 28 this is what diameter, it is 40 length. Okay, now we are going to do write a program how to write. Early this box turning cycle, what is a box turning cycle, how it will be function. So the box turning is just a box type movement of the tool, that is the tool entry point is here and it will come downward, it has to go to the z direction, z minus direction, it will move upward and it moves to the z positive direction. So x reduction in the diameter, moving z minus, and moving x in upward direction, the diameter is increases, then it will move to the z1 or z positives. So this is how it is normally, but it is this. So the tool has to come here, move upward, and up to this it has to remove, then only we will get this shape. Okay, so for that we can use the G90 code, which is the box turning cycle, and for that G90 the syntax, the format how it has to be written is G90 X, Z and F. Okay, X, Z and F, which is where the X is the diameter as we said, and Z is the length of the distance what we have to make it, and F is the feed rate. So by seeing this we will go for this program. Already how we have written is, first we have to write a program number. The program number, it should start with a letter O and box turning. This is what we have kept in a bracket. It's for our convenience. It is not necessary for while writing the simulation for turned out. So but please put it in the bracket what box turn, and the raw material size, what is the maximum diameter and the maximum length, that is the X34 and the Z60. Then what type of unit, whether it is metric unit or inch. So G21 it shows the metric unit, and G98 is the feet per minute. Then it should start from the home position. So I am writing G28 U0 W0, and the selection of the tool, how it is going to be selected is M06 tool number 1 and with offset number 1. This is what the tool is set in the turret head. And M03 1200 or something else, it's a speed. M03 is the spindle clockwise rotation, and this is spindle speed. Okay, it shows the spindle speed, but it should be in the order. Okay, right. Next we will start the program. That's once the head of the portion is over, then we are going to write the tool how it has to move it. So G00, as we said, the tool is now, it is selected here. The tool number 1 is here at the home position. That's what G028. Okay, G28 U0 W0, which is the home position of the tool. So there in the home position, the tool is ready to move. So that tool, now imagine this raw material is like this. It's a raw material. Normally raw material will be a rectangular, cylindrical, round job. Okay, this is the diameter of 34. The tool has to come to this position, and then it has to take the material. So I am bringing the tool to the 34 Z1, because 34 is the diameter. So 34 Z1 in the sense it will be staying 1 mm away from this. This is the gap it will maintain. So 1 mm distance it will be there. Then now I am going to use, instead of writing step by step all steps, I am going to use the G90 codes. G90 is the box turning code here. So G90 the use, what is the maximum diameter is at 34, and for a length of z minus 40. So for this 34 is to be reduced to 28. Okay, you can see this sketch from 34 to 28 for a length of 40 mm. We are going to remove it. So first G90 30 x 34 z minus 40 I am writing, and then I am just reducing 33, 32, 31, 30 up to 28. But this z will be followed. So we need not to type again and again, since the G90 is there, the code is there, automatically it will be considered. The 34 is going to be reduced from 34 to 28, and it is maintaining the distance of z minus 40. So the turning from 34 diameter to 28 diameter for the length of z minus 40, that is needed here. So the box turning, then again the 28 I have reduced from the 28 to this 16 mm diameter for the length of z minus 22. So by reducing for that also, we have to use the same G90. So from the G90 x27 z minus 22, because the distance is for 22 mm. This 28 is going to be reduced as 16 mm. Okay, so for the entire distance of 22 mm. So from this point to in this point, we are going to reduce, the diameter is going to be reduced. So for that, we are going to reduce G90, we are going to use the G90 x27, 26, 25, 24, 23 and x16. 1 mm just I am showing, then 2 mm also we can show it, no issues. So the 28 to 16, it is going to be reduced automatically. This box turning will take place. So the movement of from 30 to 28, and it will move to minus 22. Then like this entire one cycle will be repeatedly happening until it reaches 16. So again from 16 to 10, okay, this area we are going to make it. So for the distance of 10 mm. So for the distance of 10 mm, what we are going to do is, since it is 16, so diameter is already 16, and I am going to reduce from 16 to 10 for a distance of z minus 10. So G90 expecting z minus 10, 14, 13, 12 and so on, x10. So this is what first we are going to do, and once if it is done, then we are going to finalize with the G28U0W0. There is a home position written, and stop the spindle. Since it is spindle is rotating, imagine that it is already rotating, we have to stop the spindle. So and then we have to stop the program by using the M30. So this is how we are going to write a program. Once a program is written, then we are going to make the simulation area. Okay, let me go for the simulation portion here. So this box turning, this is what it is given. For this entire box turning, we are writing the program. Then we are after this program, then we have to go for the simulation area. Okay, let me go for the simulation. How to do the simulation, we will see. Once this is done, then we will go for so I am going for the simulation area. Okay, this is what the new and see, then if you are we can select to this NC term. Again we will go for NC term, and I am opening a new window for the new program. Okay, fine, let me see. So create a new part, it will be open, and after this create the new part, you have to write and copy the paste what already we have discussed here in these cases. So the multiple turning, what code we used, that is a G90 program. So this G90 from this content, all I am going to copy paste. So in this area, so we have to ensure that it should be in a straight way, that I will tell. So first let me copy paste this. At the end, right. So copy pasted, but it is not in order. So then we have to make it edit or enter the program to keep it in order. So first go over the top and line by line. So below it should come down, and this it should come down, paid material, and after this one by one we have to be careful. Everything should be in the line by line, otherwise it won't do the operations properly. So here this is x30. We are just editing. This program should come down. And moreover you can see that's brackets, so please be aware of that. Brackets should be closed or you need not write the brackets. And how we have written in the program the same method, this should be there. So all x21, x20, x19, x18, x17, x16 like this. So now the G90 for first type of first box turning is done, and then 15 to we are going to reduce this diameter this. So just like the same it should be. So 34 to 28 is done, then 28 to 16, 16 to 10 we have to do it. So copy paste, or you can type it directly here also. Now minus 15 to 10, okay, for 10 mm length. The diameter is going to be reduced from 15 to 14, 14 to 13, 12, 11, 10. So use capital letters. Okay. Okay, that's done. Then once the program is done, then G28, U0, W04, return to home, M05. And 30, right? So this is what it is being done. Once this is over, then we have to go for syntax, okay? And we have to check whether our program is correct or not, okay? And blank, we have to make first of all blank. What is the raw material size is given? What is the raw material of the length and breadth? What is the over here it is there 3460. If it is not there, then what is the measure diameter and the length that is provided, that we can take it as a 3460 here for this animation. 3460. So blank, that's length is 60 and go for 34 for the diameter, and start with the 0 always. This is the rough. Okay, start with the 0, give OK. Now it is been done. And machines, so select OT type O for this simulation. And the syntax, so if we go for the syntax, it will show if there is any error. If there is any error, then we have to correct it. Okay, fine. So then double click here the tool, which is the external tool we are going to use it. So here I am going to use the tool like this, and edit tool geometry. I am going to nose radius, I am going to reduce this 0.2 nose radius. So it will give a sharp area over there, and give OK. Give OK again, I am giving OK, giving OK. So this is what that is done, and then syntax is done. So it is to be played. So I can select line by line. You can say here play. First if you play, then you can see here, click, it goes for metric data input, and here it will display all the values. So line by line I am selecting. Now the tool comes to the turning position. Okay. So now one by one it will move, because since it is box turning, it will, once everything is completed, then only it will go now, right? So this is the thing has happened. So next one is, you can see line by line. This is what 25, 24. So sometimes simulation may show very slowly. So the either we can select, if you want to replay it, you can replay it. So stop and play again, so that we will make it. Okay. Otherwise, go for full step, then we can go stop and play it again, simulate. So if you go for simulate, here also we can see front view, side view and all, but the thing is common, we will go for the same. Okay. We need not to change any settings over here, and normally we just play it. So this is how it is to be done, a simulation. You can see the simulation of the box turning, and the blank you should be aware of clearly what the blank you have given. If blank is not given properly, then it will go in a different manner. So that's what block, what it is mentioned here, 34 z 60, that we have to make it clearly, 34 diameter, 60 diameter, and start with this thing. And if there is error here, because of G90 is not in a line. Okay, so now once this is, that's what from the beginning we are saying, the G90 and the course, it should come in a straight line, okay, in order. Otherwise it will mismatch your shape, what is the program it is there. Now we can check it after the correction. You can see now how it is been done. So we can move downwards this, but the graphic, it won't be displayed. So again you have to stop and it can play. So the graphics display, once if it is getting disturbed, then it will come. Just close it. Sorry, cancel. So if we move anything, this graphic display will over. It won't come again. So for that, what we have to do is, we have to stop, Control A, Control C. You have to make a copy paste again. So we can open a new one and do that, or else we can close it and save it. So this can be done by selecting this. Once again I will make a paste of this, a new folder. There we will make the 60 length and 34 diameter. That is okay. Machine, you select the machine, always the first one. Syntax I'm going to check. If there is error, it will show the error. If not, it will work. Select the external term, select the term, one tool, yeah, edit geometry. I'm going to give 0.2 radius, view, okay, view, okay, okay, then play. So now syntax is over, tool selection is over, then we have to play for it. So just select this end and we can play it. So the tool will move and for the dimensions given. And if you want to fasten it by using this cursor, we can move the tool very faster, little bit faster over here. So this will be moved. That's all. So this is how it is being done. Okay, backsliding. Once this is done, then we will find the result. We have to write the result over there, what the program for the event sketch has done, and the simulation is executed. Okay, this is how we have to do it.